Everyone, so just now we finished the basic overview of EIGRP. That is also very important. We need to remember these points. Whatever I wrote here, these all points are very important. Try to remember that one. Okay, and we need to remember, if you remember, I did not mention here the number. If you remember, OSPF is having the protocol number is 89. EIGRP is having the 88. So this one we need to remember. Okay, OSPF is using the 89 and EIGRP is using the 88. So this is sometime in interview they will ask you this question also. This one we already check and we already write in our notes. Here I think I wrote somewhere in between, but here in the introduction I did not write. That's why I am saying here EIGRP use protocol number 88. Okay, so let's do the lab here. I will take here create new lab, or here also let me show you the protocol number, EIGRP protocol number, let me write here number, that is 88. See this one, this is very important. In interview you will get this question, EIGRP protocol number, OSPF protocol number. You need to remember this one. OSPF is using the 89. Okay, OSPF using 89, EIGRP is using 88. This one you need to remember, this two number protocol number. So now let's do the basic EIGRP lab. So let me take some router. Any router we can take. I will take this one, the one which we are using from long time. I will give the name as a R, and here number of quantity I will take 2. Here I can add the interface. Let me add the fast Ethernet. Here also fast Ethernet. Remaining will be same. So we can take 2, no issue. If you want 3, 4, but first basic lab we will take only 2, because concept is very important. Once you get the concept, once you understand everything, you can take number of routers, no issue. So let me give here IP schema 192.168.12.0/24, and here I will change this as a 15, and this is a bold, and here we can give any color. Let me take this color. Okay, this is the IP schema we are going to use, and as we told, we will have the loopback here. So I will create loopback 0. Okay, and IP address, whatever IP we want we can give. So let me give here 1.1.1, as we are using, this is the router 1, so I will use 1.1.1. /8 I am using. If you want to use /24, whatever you want to use, you can use. Okay, because EIGRP is supporting the subnetting, so we can use /16 also, and /24, whatever you need. So let me duplicate this. I will keep this here also, and let me start the router. So it will boot up and it will be ready. And here I will change, this will be 2.2.2. I will give this as a 2.2.2. So 2.2.2.2. And now what else? So this is okay. Now we can start the configuration, then we can look what else we can do to these routers. So let me take notepad. I can take the notepad here, and I can do the configuration. Same thing what we done in the OSPF, only little steps is different. Assigning IP is same, other thing is same, like that only. So let me write here the basic lab, basic EIGRP lab. Let me write R1 configuration, R1. Let me take here R1 configuration. Enable config T, then host name R1, and then IP address fast Ethernet 0/0, and we can give IP address 192.168.12.1 255.255.255.0, and then we write no shut here, and then interface loopback 0, and we have the IP address 1.1.1.1 255.0.0.0. So this is the IP address, just we assign the IP. Let me configure the EIGRP also. So we will write router EIGRP Here whatever the AS number you are using, we need to use same AS to other end also. So I am using 1 here. Then we need to write network and network ID. What is the network ID of this one? This is a class A. You can check this one. Wherever you have 255, you need to keep that same thing. And wherever you have 0, make that number as a 0. So I will take this one and I will keep this here. First one is 255, so we will keep that same as it is. Second one also 255, same as it is. Third one also same as it is. Here 0, so make this as a 0. Okay, this way we can calculate the network ID. Now we will do the second one. Second one, what is this one? Okay, if you see only 1, 255, so this will be 1, remaining will be 0.0.0. So how we will write? We will write like this. Okay, so this is a network ID for 1.1.1. After that we will write no auto summary, because they are going to do the summarization. We don't want Eigrp to do the summarization, so we will write no auto summary, SUMMARY. Okay, this is a configuration for R1. Now we can copy paste same thing and we can modify. So what I will do here, let me divide this notepad. I will paste the configuration here, and now I will take this as a 2 and this also 2, and here this should be 2 and this should be 2.2.2, because we use the loopback 0 as 2.2.2, and here this should be 2. I hope no question here, because what we done, just I assign the IP address. From long time we are doing this one. This is enable config t host name, go inside this interface, assign this IP, write no shut, create this loopback, give the IP, and then no need to write no shut because loopback always up. And then router, which routing protocol you want to configure, that name, as we are doing Eigrp, so we will write Eigrp. AS number is 1. If we use 1 here, here also be 1. If we use 2 here, here should be 2. And after that network command of this interface and this interface. Here we have, this is a network command, from we will take from here, and this one also from here. Then write no summarization, no auto summary, no auto summary. Okay, no auto summary. Okay, so you need to remember Eigrp. So here I wrote typing mistake, Eigrp. Let me correct, because we will get error else. And as we copy paste, so here also Eigrp. Okay, so this is basic configuration, but anyhow we will type here also, no problem. We can type first time. So here this one is okay. I will write no here, and then I will go here in this router R2 and I will write here also no, and then we can copy paste the configuration. So first one I will copy from here to here, and other one I will show you. Okay, what options we are getting here. R1, so let me go to the R1. We are in the R1 now. I need to paste the IP address. Just I will assign the IP address. So this IP is okay. Now we need to configure the Eigrp. So how we can configure? We will write router, or let me exit this one, interface, and then router Eigrp. If you press question mark, you will get, you want to configure the autonomous number, autonomous system, AS number, or the word. This one we will learn in the NRC, not here. Encore, we will learn this one, autonomous number, how we will configure. In real scenario also we will use this one most of the time. So now I need to give number. I can give from 1 to 65535. This is the range. I can use any number. So as per our plan, we will use 1. Okay, so we are inside the Eigrp. Now we need to give the network, whatever the network, 192.168.1.12.0. Okay, then what else? Other one is a network, and then what is the network ID? 1.0.0.0. Then no auto summary, no auto summary. This is a R1 configuration. Now we can go to the R2. Okay, this is a R2. Directly we can copy paste, because already we check what is this all Eigrp. So let me copy and paste directly here everything in the R2. If we have any typing error, we will get here. Let's see, nothing, everything is good, working perfectly. And now we need to wait some time. After that we will have the neighborship. If you see here, same thing, we have Eigrp neighbor, they have the neighborship. So now what we will do, we will go in the R1 and we will check some tables. As we told, we have 3 tables in the Eigrp. So first we will write show IP route. Okay, with this one we will get the routing table. So if you see here, what we are getting, this D. Okay, D is nothing but Eigrp. If you see here, this one, because E is reserved for other thing, so they put D as a Eigrp. Just we need to remember, as O is stand for OSPF, here D stands for Eigrp. So this route we are learning from the Eigrp. If you see, this is a 2.0.0.0/8, and this is the administrative distance. If you remember, I told AD value is a 90 if they are coming the internal route. If we have external route, 170. Let me show you the one which we discuss here, this one. Okay, if the routes are coming internal AD value, default internal AD value is 90, default external value is 170. So now what we will do here, let me take R1 and let me do one more method. Write show IP route, then write Eigrp. You will get only Eigrp route. So here you can see, this is the indicating we learned this route from the Eigrp, and this is the destination, and this is the AD value, and this is the metric we have, and this is the next hop, and this is the time from what time it come up. This is the living interface. Okay, and if you want to check other table also, we can check, but before showing that one, let me explain you here in the notes. Let me explain you. So if you see here, this is the routing table. Just now what we discussed, same thing here. After that we have the Eigrp neighbor table. How we will check the Eigrp neighbor table? We need to write show IP Eigrp neighbor. With this command we are going to get the neighbor table. So what we have in the neighbor table, if you see, first thing we have here H. Okay, first of all you can check, this is the IPv4 we are using, and whatever the AS number we are using, you will get that one. After that you have H. H is nothing but handle. It will show you the list of the neighbor in the order. If you see here, it is coming 0. 0 means the first neighbor. If you have second neighbor, you will have 1 and then IP address. If you have third neighbor, 2, then IP address, and which interface, that one, like that way. Now just remember, H means handle. Here it is showing the list of neighbors. Okay, list the neighbor in order to, in the order this router was learn. How the router run, which one he learn first, which one he learn last, he will show you here in this list. After that, address, that is a IP address of the neighbor. This is a IP address of the neighbor, and this is a interface, this one, the interface of the local router on which this hello packet was received. So this is our interface. If this is our router, you have here E 0/0. So this is the interface where we receive the hello packet from this router. And then we have the hold, that is a hold on time. We have here 13 seconds. That is same like that. Before we told, this is decreasing. Hold on time is we have 15. It will go 15, 13, 12, 10, 8 like this. And till 0, if he did not receive hello, this will be removed from the routing, from the table. So what we are saying, this is a hello timer, the amount of time left before the neighbor is considered in the dead, means dawn state. Same thing, actually we will have this value as a 15, and then he will do -1, -1, -1 like that. If this becomes 0, till that time, if this router, this interface did not receive any hello packet from the front router, if he did not receive the hello packet from the front router within this time interval, then he will treat that one as a dead, and he will remove this entry from the routing table, from the Eigrp table. So in simple, just we are saying here whatever the time is left to get the hello packet. And then we have the uptime. Uptime means from what time we have the neighborship. from what time we have the neighborship, from 15 seconds. Then we have SRT, that is smooth round trip timer. So if we are sending any hello message from one router, example this router to this router, if we are sending any message, it will go and come back. How much time it will take? That is known as smooth round trip. It is taking 10 milliseconds. This will be in the millisecond. And then we have the RTO. So retransmit timeout. So if like whenever one guy is sending some update, other guy is not replying, so he will wait for some time. He will wait for time. If the time is out, he will again resend the packet, and this time will be in the millisecond. After that we have QCNT, that is a queue count. Like whenever we are getting the many packets, it will be in the queue. So how many packets we have in the queue, that will be indicating this one. So we don't have any packet, and this is a sequence number. Sequence number is indicating that the sequence of the update of the EIGRP packets. After that we have the EIGRP topology table. Topology table consists of all the topology, same like this. You will get here as a AS, whatever the AS number you are using, and you will get the routes, you will get the successor and feasible distance. We will look what is successor, what is feasible distance in the coming lecture, so no need to worry. Now just remember here, passive means it is working perfectly. If you have active means it is having some issue. So here we are getting passive means all are having okay, no issue. And for going to this route, we have only one successor. One successor means best route. We have only one best route here. Here also one best route. Here also one best route. If you see here, let me show you. I wrote here AS means autonomous system number 1, and code passive is good. Here this one active means not good, something wrong. And after that, what I told here, state struck inactive. Like whenever we have active, we will have the issue, we will not get reply, so it moved in the active. If it is having passive, no issue, it is working perfectly. And the successor, this one, successor is nothing but the best path in which we will go to the destination, means the best path to go to the destination, that is the successor. And we have FD. FD is nothing but feasible distance, that is the total distance to go to the destination. So when we do the lab, you will understand, we will get this in detail, how we can calculate the feasible distance and whatever the successor, we are going to check that one. Now just remember what detail we are getting. In the EIGRP topology table, we are getting the AS number. After that, what we are getting, these routes are in the passive or active state. Passive means good, active means some issue we have, and what is our successor, how many best path we have in the to go to the destination, that is successor, and total distance is FD. Feasible distance is a total distance. So if you see here, total distance is 281600, that one. And if you see successor means we have only one path to go to the destination, the best path. We are going to see that one. And how we can check the routing table, show IP route. If you want to check only EIGRP path, you can write show IP route EIGRP. So with this one you will get the EIGRP only detail. So D means EIGRP, and this is the destination network, this is a matrix, this is a cause, and this is the next hop IP, this is the time, from what time they are up, and this is the leaving interface. So this one, same thing what I told. D means this one, this is the 90 is nothing but AD value, and this is 40, this one is a matrix, that is the total distance to go to that one, and this is a next hop, and this one is the time, from what time they are up, and this is our interface from where we can send the packet. So let's see these tables in our here. If you see, first table we check the routing table. Now we can check the database table, and we can check the neighbor table. Database means topology table only. So let me write here show IP EIGRP neighbor to check the neighbor table. So here what I am getting here, if you see here, we are getting this is a 0. So first he learn this neighbor, and this is a neighbor IP address, this is the interface, our local interface, this is a hold on time. Hold on time, I hope you remember 15 seconds we have. So this will be reduced 15, 14, now it is 13, maybe again if you check now it will decrease. Okay, it is start again from 15, so it came 14. Now if you check again it will change, it is 14 still, now it is 10. Okay, this is a hold on time. Both are sending hello every 15 seconds. They will wait till 15 seconds. So this is a dead timer. In OSPF, as we told, hello timer, dead timer, same here. Here we have the 5 to 15. Hello will be 5 seconds, 15 will be 10, 15 will be dead timer. And this is the uptime, same thing what we discussed. This is a what table? Neighbor table. In this one we are going to get the neighbor detail. After that, what we can check? We check the routing table, we check the neighbor table, we have the topology table. So we can check the topology table now. So topology table, what we will have in the topology? All the topology details. So how we can check? We can write here, let me move this up. Show IP Eigrp topology. Okay, press enter. So here, just now what we discussed, we will have here. If you see this all are P means everything is okay. If you see active means something issue, some route will stuck in the active state, but now everything is good, no issue. And if you see this is a one successor, means best path to go to this network, we have only one best path, and total distance how much it will it need to go there, this much distance. And if I want to go to this network, this is only we have one best path, and total distance will be this much. And if I want to go to this one, same thing, I have one path and this is a total distance. So we will see now when we do some more lab, you will have the idea. So this way what we done, we learn the basic Eigrp configuration and the basic table structure of Eigrp. After that we will learn the metric also, metric of Eigrp. But let me stop